So now we get to a situation where we have this is an RLC parallel, so resistive, inductive, capacitive parallel. And things don't change too much. We just have to sort of follow, our rules that we've already prescribed for, circumstances like this. So when I look at this, I got 120 volts. Where's my cursor hand? There we go. So I look at this and I go, okay, I got 120 volts. I know my resistance here. I know my voltage, and of course I'm parallel. So if I know my voltage here, I can find my current here. If I know my voltage here, and I know my reactance here, I can get my voltage. So right. So I mean, this is a fairly easy start for us. So like right off the bat, we can just go boom. We can drop those values in. And then, as soon as we do that, then we can just move right on to our currents, right? So step number one, I would say IR is ER over R. So the voltage is 120 divided by 30. So I've got 4 amps here to start me off. So 4 right there. And then we'd say step number 2, we could do this one here because we didn't have to use our 2 pi FL or our 1 over 2 pi FC. I've already given them for you here. And you guys know how to do that anyway. So step number 2, we'll say IL. IL is EL over XL, 120 over 60, easy peasy, 2 amps. Okay, I could also say, okay, well, that's 2 amps at 90 degrees, right? Off from this one here, but whatever. Step number 3, IC is EC over XC. So 120 divided by 40, right? By 40, yeah. So 3, so I get 3 there. Kind of nice, easy numbers. Don't even have to use any calculator from the get-go. So if I was to sort of look at this, I go, okay, well, I would mark this as IC because if we're thinking in terms of amperage, voltage there's no problem. We're not going to have a voltage triangle because we parallel here, but we are going to have a current one, right? So if I say, okay, that's IC because Eli the Iceman, right? Amperage being out ahead, this would be IR, and of course this would be IL. So if I said IC, we're saying is 3 amps. So I'll say, okay, well, that's, I'll put it right there. So IC, and then let me write that down. IC is 3 amps. IR, we're saying is 4 amps. So I'll write that there like that. 4 amps. And then IL is 2 amps. So I'll put that somewhere around over there. So that is my IL is 2 amps. So, I would go, okay, well, 3 minus 2 gives me 1. So I would mark this one out here as being 1 amp. So I would say, okay, well, that would be my amperage XT. So I could go like this, like that, and then draw it like that, showing that the current is ahead. I have capacitive and I have inductive and resistance. We know the capacitive is ahead because of, Eli tells us this, Eli the Iceman. So I would sort of draw like that. So let's take a look at what. Now this is just determining my capacitive value, my total reactance as a result of my capacitance, just to determine that. So let's take a look at what my I xt, I could say IXT equals my I, this should be L, IXL. My IXT would equal my IXL plus my IXC, right? Which is what we've done there, right? So, and just writing it, 2 amps plus the negative value is 3 gives me a negative value of 1, right? But we're not gonna worry about it being a negative value. I could say, if I said it's a negative value of 1, I would lead to say that it's a capacitive. We can find out what this value is here by saying, okay, well, my IT, or IRMS, would be equal to my vector sum of the two. In other words, my IXT squared plus my IR squared. So if I put that in here, my IXT we know is 1. Right? That's that number there. So 1 squared plus my IR, which is my IR is 4 squared. So I end up, if you do that, you end up with 4.12 amperage, and that's your IT.